everyone. My name is Sindhuja, working as an assistant professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology, Hyderabad. I welcome you all with another video lecture on stream processing and analytics. Today's topic is Spark components. So, in the previous lecture, we have learnt about what is Apache Spark and how it is useful in distributed stream processing. So now, in today's lecture, we are going to learn what are Spark components. So in today's lecture, we are going to learn what are Spark components. So my overview of today's presentation is that what is Spark Core, Spark SQL. As a third part, we are going to learn Spark streaming, and as a fourth part, structured streaming, and next ML library, and finally we are going to learn about GraphX. So what are all these Spark components? We are going to look into it. So now let's start with what are the Spark components. Spark project consists of different types of tightly integrated components. So here Spark has multiple components which are integrated tightly. As its core, Spark is a computational engine. So as I have told you in the previous lectures that Spark works as a core engine, okay, core engine in between data source and data sink. Okay, data source is nothing but, as you can see here, data source is nothing but, we can say it is an input, and data sink is nothing but where we are storing our output, our data. Okay, so in the middle it will work as a Spark core engine. Okay, so it will transform the input data into output insights. Next, computational engine that can schedule, distribute and monitor multiple applications. So as it is working as a Spark engine, so it will schedule, it can schedule, distribute and monitor multiple applications. So to multiple applications it will distribute the work. So Spark consists of a core engine, a set of abstractions built on top of it. So it has a set of abstractions which are nothing but the necessary data it has to show and hiding unnecessary data, represented as horizontal layers. So in the next slide there is a diagram. So in that it is represented via horizontal lines, and libraries that use those abstractions to address a particular area. So and it also uses libraries with respect to abstractions, and those abstractions are worked on each and every library. So those are represented in vertical boxes. So how we can represent? By using a diagram all these abstractions and libraries. So here you can see as a vertical boxes and horizontal boxes. So these two are the Spark abstractions as well as Spark libraries. So the horizontal and vertical, here the horizontal boxes represents the abstractions, okay, core abstractions, and these vertical boxes are representing libraries. Okay, multiple libraries which can integrate with a Spark core as an abstraction. Okay, as an abstraction. So all these combinations of abstractions and libraries can perform on a Spark core engine on a multiple data sets. So here in this diagram we can see there are 6 components, right? As I have told you that there are 6 components. So here is Apache core is our first component, Spark SQL is a second component, structured streaming is third component, and data frame is, and it is one of the abstractions, and next graph frames and Spark ML library and Spark streaming. All these are components of Spark. Okay, so we'll go deep one by one in detail. Now we'll look into the first component, which is nothing but Spark core. So contains the Spark core execution engine. So it is nothing but, it is a first layer in a Spark component. It is nothing but the execution engine. Okay, it works as an execution engine, a set of low level functional APIs. Okay, it has a set of functional APIs which used to distribute computations to a cluster of computing resources called executors in Spark. So here this Spark core works as a distributed computing which can distribute the work to particular cluster machines, as I have told you in the previous lectures. So the work is distributed among multiple clusters machines, right? So it is a master, and these are, we can call it as a executor machines. Okay, each and executor machine works in a parallel in a distributed manner to complete the tasks. So the task 1 is assigned to executor 1, task 2 assigned to executor 3, and task 3 assigned to executor 3 machines. So all these executor machines works parallelly, and they share resources. Okay, they share resources among themselves. So these resources allocated by using Spark core. So this will works as a distribution engine. Okay, so its cluster abstraction allows it to submit workloads to Yarn, Mesos, and Kubernetes. So here Yarn, Mesos, and Kubernetes are nothing but these all are called as clusters. So types of clusters, we can call them as a types of clusters. Yarn is a first type of cluster, Mesos and Kubernetes. So these clusters work and with a multiple devices to achieve any goals or any tasks. So as well as we use its own standalone cluster mode. Also, Spark has its own standalone cluster which works in a distributed manner, in which Spark runs as a dedicated service in a cluster of machines. So here in Spark, that standalone clusters may work as a dedicated services in a cluster of machines. So if the multiple clusters work parallelly in a distributed manner, so those services are dedicated among themselves so to perform any tasks. Its data source abstraction enables the integration of many different data providers. So here, if the data is collected from multiple sources, so that many data providers are going to work here in a first step. Here the data source, this is nothing but data source. So here as a first step, multiple data providers are work on multiple files. Let us take an example such as files, block stores, databases, and event brokers. So these kind of storage devices works on basis of the data storage by service providers. All these file systems available at the first stage of data collection, which is nothing but data source. So now we'll look into second component. The second component is nothing but Spark SQL. So here Spark SQL works similar to normal SQL database. As you know that SQL is nothing but structured query language. So here we can work with the databases and we can create the tables, we can retrieve the table, we can update the table. How we are going to perform multiple functions and multiple operations with the databases in the same manner with the Spark SQL, we can perform multiple queries like SQL. So we can say Spark is providing SQL based of operations which is similar to SQL database. So here instead of taking tables and all, we can replace with the multiple file formats as well. Okay, file formats which we can take it as a SCSV, JSON, and Parquet file. Here we can, in the same manner, we can query these files as well, which is similar to SQL databases. So now we'll move deep into this topic. Implements. Spark SQL implements the higher level data set and data frames. Here APIs. Here it will works with high level data sets and high level data frame APIs of Spark. Adds SQL support. Here, as I have told you that just now, it will support SQL query supports top of arbitrary data sources. So we have multiple data sources collected from multiple places, and those data can be stored on one database or one file format, and we can query this particular files by using Spark SQL query optimizers. It also introduces a series of performance improvements through the Catalyst query engine. Catalyst query engine. This is one of the component in SQL, Spark SQL. Okay, Catalyst query engine. So through this we can query multiple file formats, and code generations and memory management from Project Tungsten. So here in the form of query engine, we can query multiple files which is related to Spark SQL. So now let's move on to the next topic. So our next component in Spark is Spark streaming. Okay, Spark streaming. Here the word streaming means we are working with a continuous data. Stream means it is a continuous flow of data. So Spark streaming was the first stream processing framework. Here we can say this was the first and foremost stream processing framework built on top of the distributed processing capabilities of the Spark core engine. Okay, this is built on top of Spark core engine as a first stream processing framework. So on top of means which will developed as an advanced feature of next thing. Okay, it was introduced in Spark 0.7.0 release in February of 2013 as an alpha release to process large scale data streams. So it was introduced in Spark 0.7.0 release version in the February 2013 as an alpha release to process large scale data streams. Okay, Spark's distributed computing capabilities to stream processing by transforming continuous streams of data into discrete data collections on which Spark could operate. So here in Spark distributed computing, we are collecting the stream of data here, continuous flow of data, and dividing those data into some discrete data sets. Discrete data sets is nothing but here we are dividing the data into multiple different formats or different batch vises. Okay, we can distribute the data into any other partitions. So that is nothing but we are dividing the data into discrete data collections on which Spark could operate. So here individually processing those parts is easy when comparing with the processing data at a time. So why? Because we can get a parallel processing features as well as distributed processing feature while working with the individual components and individual data. This approach to stream processing is called micro batch model. Here we can call it as a micro batch. Micro, the word meaning is small. Okay, the micro word meaning is small and batch is nothing but a chunk of data. So here instead of working with a large data set stream of data, here we are dividing that data set into small batch of or small chunk of data for easy execution and easy computing instead of working on a huge volume. It introduces a new abstraction that is nothing but discretized stream or D stream. So those micro batches we can call it as discretized stream or D streams, which are different to each other, which exposes a programming model to operate on the data in the stream. So those programming concepts are applied on this particular D streams or discretized streams to get the outputs or to achieve the goals or to get the proper outputs. So now let's move on to the next component. So which is totally opposite to Spark streaming. So this is another component in Apache Spark, which is nothing but structured streaming. So structured streaming is a stream processor. It is also one of the stream processor built on top of Spark SQL. Okay, it will build on our second component, right? Spark SQL is nothing but our second component. So this was built on top of that Spark SQL. So we can say structured streaming is an advanced version. It added some more features. That is the reason it has built on top of Spark SQL, we can say abstraction. It extends the data set and data frame APIs with the streaming capabilities. As we can compare with the Spark SQL, here we are working with the data sets and data frame APIs with the streaming capabilities. Streaming capabilities in the sense here totally we are storing the continuous flow of data into the data sets or data frames. Okay, instead of storing on any databases or any file formats, we are storing continuous flow of data onto the data sets or data frames and to work with the Spark. As such, it adopts the schema-oriented transformations. Schema-oriented. So, every data is converted as schema. Okay. Here, every data which is stored on data sets or data frames converted as schema so that it is easy for us to manipulate or we can store the data onto the based on the schema. which confers the structured part of its name and inherits all the optimizations implemented in Spark SQL. So that that schema has the structured part of its names and inherits all the optimizations which are implemented in Spark SQL. So Spark SQL, it has also implement some of the features or properties from Spark SQL with a combination of new advanced features. That is the reason here we can store a continuous flow of data into the data frames. Structured streaming uses a declarative model to acquire data from a stream or set of streams. So here in the process of data usage, it will use this declarative models to acquire the data from one stream or set of streams. So here set of streams are nothing but data is continuously generating on a set 1, set 2, set 3 basis. So which is nothing but set of streams. One stream is a continuous flow of data and set of streams are that continuous flow of data as a sets. To use the APIs to its full extent, so we can use those APIs to the full extent or full capability. It requires the specifications of schema for the data in the stream. So to use the APIs to the fullest form, we have to specify with the schema. Then only it is easy for us to store the data as well as to retrieve the data and to implement any transformation functions or actions on that particular schema oriented data. So that is the reason we have to use its full extent of the data APIs. So now we'll move on to the next component. So here the next component is MLlib. MLlib is nothing but ML represents machine learning library. Okay, here ML represents machine learning library. Okay, here as a library, a machine learning library, it will integrate easily with the Spark. So ML library is a library of an algorithms as an important part of the Spark. So as everything is machine learning, machine oriented these days. So here we can say that it is a library of algorithms. So machine learning especially implements algorithms and some techniques to achieve goals, right? So it is an important part of the Spark. Why? Because to work with the continuous flow of data and modeling that kind of algorithm requires a very complex techniques and tools. So machine learning will provide those algorithms and technologies. It enables large scale data processing on machine learning. Okay, it enables large scale data processing on machine learning data processing. So which Spark especially integrates easily with the machine learning libraries. It was developed for speedy and interactive computing, especially machine learning library. As a part of Spark has developed for speedy and interactive computing. So with the continuous flow of data, we can achieve speed processing and in the same time interactive components as a Spark components. Each and every devices and technologies interact very easily that operate in storage. It contains various implementations of algorithms. Okay, it has multiple implementations of algorithms with the combination of Apache Spark. So as a last component, we are going to look into GraphX. Okay, which is represents the graphical representation of the data. So this kind of graphical representation, okay, is mainly useful for the visualization purposes, right? So GraphX is a distributed graph processing platform. Here we can say that a distributed graph processing platform, which is related to diagrams and showing outputs through graphical representation based on Spark. It comes with a variety of graph algorithms and versatile APIs. So GraphX is a combination of graph algorithms, machine learning algorithms as well as versatile APIs. It implements the API concepts as well as a part of the GraphX. Developers use this to work with the graphical data. Okay, especially this is useful for graphical data representation and exploratory analysis and for exploring the data. So what is the meaning of exploratory analysis? Here the EA represents we are going deep into the data understanding. Okay, exploratory is nothing but inventing the new things, exploring the new things, or inventing the new things from already existing data. Okay, first of all we have to look into data and explore new things out of the existing data. Okay, that is nothing but exploratory analysis, and many more. It helps users to use graphical data for creating their applications. Mainly, it will be useful for, creating multiple applications by using their graphical data, which are represented via multiple libraries. So, especially for business purposes, this kind of applications has to show via graphical representation. So, for getting profits and showing, understanding and showing the data in a simpler way, this kind of libraries can help. With Apache Spark features, there may be chances of getting more profits, and they can easily interact with the complex data. So all these comes under Apache Spark components. So we can integrate all these components easily with the Apache Spark. Based on the project or based on the scenarios, each and every library has their own features to integrate with the Spark core engine, which can implement all the data in a simpler and faster manner. So thank you so much for your time and attention. Thank you.